tutorial question number 2 for vibrations. Again, extract the information so we know the mass, the acceleration when it's 30 millimeters away from its midpoint. So there it is, 30 millimeters, 0.03 meters. And first of all, we've got to find the frequency. So this is very similar to tutorial question number 1. Identify the relevant formula or formulae and then put in the information. So again, we're after the frequency, and the frequency is related by omega equals 2 pi f. And we also know that A equals omega squared x. We know A equals omega squared x, so we can then rearrange and find the value for frequency. And we get frequency of 2.05 hertz. So for the second part, we're given that the amplitude is 50 millimeters, which is 0.05 meters, and we've got to find the kinetic energy. We've got to find the kinetic energy as it passes through the midpoint. So if we think about this oscillation, simple harmonic motion, which will look a little bit like this, as it passes through its midpoint, that's when x equals 0. And you remember us talking about certain values, and this was one of them. We get maximum velocity as it passes through its midpoint. So we need to find out what the velocity is when x equals 0. And if you look at your formula sheet here, you're given the formula for the velocity. So if x equals 0, this formula becomes a lot more straightforward. And in fact, V equals omega r is the formula that you need. So in this particular case, V max, the maximum velocity, equals omega r. And that's a formula that you're not given, so you need to remember it. But it comes from the formula on the formula sheet where x equals 0. So to get the kinetic energy as it passes through its midpoint, we're after this V max. So you use omega r to calculate that, and then we plug that into the formula for the kinetic energy, which again you need to remember, a half times the mass times velocity squared. So once we've got this maximum velocity, we can find the kinetic energy as it passes through the midpoint. So go ahead and do the calculation. Okay, so if we look at it from the first part, omega turns out to be 12.9 radians per second. The square root of A over x from this formula here. And then, once we've got omega, we can find V max, because that's just omega r. And then once we've got that, we can put it into the kinetic energy. A half times the mass times the velocity squared gives us that kinetic energy.